So here we're trying to show that the diagonals of a parallelogram meet at right angles if and only if the parallelogram is a rhombus. They've set us up well to start with. They've said that OA is little a and AB is little b. So what do I do using vectors if I want to show that two lines are at right angles? Well, I have to show that the dot product is 0. So I'm looking for OB and AC. And actually, with the way they've set up the letters, it turns out to be easier to go CA instead. So I'm going to go OB dot CA. OB dot CA. Now, OB is the same as little a plus little b. And then CA is a little harder to see, but it's A, because this is the same as A minus B. A minus B is the same as going here. Okay, let's expand the brackets. A dot A, firsts, outsides minus A dot B, insides plus B dot A minus B dot B. Well, A dot A is just the length of A squared, and B dot B is just the length of B squared. B dot A, remember the dot product is commutative, so B dot A is the same as A dot B. So I've got minus A dot B plus A dot B, and they go away. So all I've got is mod A squared minus mod B squared. Now, if these are at right angles, then that's 0. In which case, the length of A must equal the length of B, and I have a rhombus. Conversely, if the length of A is equal to the length of B, and I'm starting with a rhombus, then this minus this will be 0, and these two vectors must be at right angles. And we've proven what we need to. But we do need to say some of that. So, if OB is perpendicular to CA, then OB dot CA equals 0. Oops, that was meant to be then. So mod A equals mod B, i.e. What's it called? OABC is a rhombus. Okay, so that's one direction. And then the other direction says, and if OABC is a rhombus, then mod A equals mod B, and then from what we just shown, so OB dot CA must be 0, which is to say that OB is perpendicular to CA, and therefore the diagonals are perpendicular. So I have shown that if the diagonals are perpendicular, then I must have a rhombus, and if I have a rhombus, then the diagonals are perpendicular. So I've now proven that diagonals of a parallelogram are at right angles if and only if the parallelogram is a rhombus. So I can go QED. I'm done.